Hi, and welcome back to the Public Gardens GIS video training series. This is lesson 2. Today we're going to talk about how to download and install the ArcGIS Public Gardens data model, and we're also going to take a tour of the features that it has to offer. A few things you're going to need to know before we get started is that you're going to have a few system requirements on your computer to be able to perform all the tasks we're going to go through today. The first one of those is that we're going to need to have Windows XP or higher installed on your computer. You're going to need an Arc Editor or ArcInfo license of ESRI's ArcGIS 9 or 10 software, and you'll also need read-or-write privileges on the folder where we're going to save all the data on your computer. First off, let me show you how to download the data model.
Okay, so the first thing we're going to do is go to the Alliance for Public Gardens GIS website. So to do that, go ahead and open a web browser and navigate to www.apgg.org and press enter. I've already pulled this page up here, and once you get to the page, you'll see hopefully a screen like this, but we're constantly changing and revising our website, so you may see something slightly different, but hopefully it will be clear to you in future revisions as far as where you need to go. For this current version of the website, we can either click on the main banner here to download the data model, or go to Products and select the ArcGIS Public Garden data model. And once you get to the data model page, you'll see about halfway down that there is a Download the Data Model section. And the data model is currently under beta testing, so we're going to go to our beta program page and scroll down to the bottom and select Register and Download. Once we get here, you'll see a registration form that you'll need to fill in some information, and note that the red asterisk fields are required. I'm going to use my browser's autofill settings to quickly enter this information. And this form we use to track people who are downloading the data model, so we have an idea of what kind of institutions are using it and how many are using it. And under data model modules, you want to select all, because we're going to be using hopefully all of these different parts of the data model in the lessons to follow. And under GIS project goals, enter a brief description of what you're hoping to accomplish with your GIS. And for today's purposes, I'm just going to enter training video production for the Public Garden GIS training series. And once you've entered that information, you can hit submit. And at the top of the page, it'll tell you that thanks for registering, and you may click on the button at the bottom to download the data model. And on the download page, you'll see at the bottom a number of different things that you can download. Now, if you're using ArcGIS 9.3, you'll see the second link here is for downloading the data model appropriate for that version. If you're using ArcGIS 10 or 10.1 or a later version, you can download the model for ArcGIS 10. Now, in the future, you may see one for 10.1, 10.2, and future versions that aren't out yet. But right now, if you're using ArcGIS 10.1, the version 10 of model will work just great for you. You'll also see a link to download the ArcGIS Public Garden Data Model Poster, which is a technical reference for how the data model is organized and some detailed views of some of the plant and related feature classes. And then additionally, you'll see our Getting Started document, which contains instructions for getting started with data model. Now we're going to be covering most of the subject matter of that document today, so we're not going to be looking at that document, but it's a good idea to download it anyway. Okay, so we're going to go ahead and click the download link under the Get Starting document, and I'm going to save that in my Documents folder and create a new folder for the institution that I'm currently working at, which is the UC Davis Arboretum. And in that folder, I'll save the Getting Started document. And I'm also going to be using ArcGIS 10 for these videos, so I'm going to download the ArcGIS 10 version of the data model and save that with the default name into the same folder. And once that's done downloading, I can close my web browser, and we can go ahead and open up Arc Catalog. So from the Start menu, go to All Programs, go to ArcGIS, and go to Arc Catalog 10. And in Arc Catalog, I'm going to maximize it so it fills my screen here. And then on the left under the catalog tree, you'll see folder connections. And what we're going to do is create a folder connection to the folder that we just created where we downloaded our files to. So I'm going to hit the Connect to Folder button under the Edit menu here and navigate to the place where we saved our files. It's the UC Davis Arboretum folder. This may be a different name for you. And click OK, and that basically creates a shortcut to that folder within ArcGIS that'll help us quickly navigate to where we saved our data and where we're going to create our GeoDatabase. So the next step is within that, once you click on that folder connection that we just created, I'm going to right-click in the blank area to the right and click New File GeoDatabase. Now we're going to use the File GeoDatabase today because it is the preferred GeoDatabase format for ArcGIS. It performs better than some of the other options. But if you are using or plan on using Trimble's GPS Analyst software, which is an extension to ArcGIS for post-processing GPS data collected with a Trimble device, you want to select Personal GeoDatabase. Otherwise, we're going to go with a File GeoDatabase. Once we create that, we're going to rename it to temp. That signifies that it's a temporary geodatabase, which we're later going to delete after we've performed a few more steps here. So once that's created and renamed, we can right-click on it and select Import XML Workspace Document. In the resulting window, under What do you want to import, we're going to do Schema only because the data model is a blank, empty geodatabase schema or template. It doesn't contain any data, so there's no need for us to select the data option. And then it says specify the XML source to import. We're going to use the Browse button and navigate to our new folder that we created and saved our files in, and select the XML document for the data model. And click Open, and then click Next. And then it brings up a screen that shows all the different objects that are within the data model that's going to be imported into our new geodatabase here. We can just acknowledge that those are there and hit Finish. And it will start importing all of those objects into our geodatabase. And depending on the speed of your computer, this could take a little time. So we'll just sit back and let this finish and pick back up when it's completed. Okay, once that process completes, that window will automatically close, and we can go and double-click on our temp geodatabase here and see that all the different objects of the geodatabase template or data model have now been imported into this geodatabase. And for now, that's all we're going to do. So we can go ahead and close our catalog. And to perform the next step, we'll go to our Start menu and open up ArcMap. So go to All Programs, go to ArcGIS, and ArcMap. Okay, once ArcMap opens, it starts with this Getting Started window. We can select the default option of a blank map and hit OK. And then what we want to do is add a layer out of our temporary GeoDatabase into here, and we need to assign a coordinate system to it. The data model comes empty with no data in it, and it also comes with no coordinate system or spatial reference assigned to it. And that's because depending on where you live in the country or the world, you will use a different coordinate system. So to add a layer in, we'll go ahead and select the Add Data button here. And under Folder Connections, select our connection to our UC Davis Arboretum or whatever you've named your folder. Go into our temp GeoDatabase and go into the base map feature data set here and select the top layer or feature class, the area of interest feature class, and click Add. And this window comes up saying that there's an unknown spatial reference for this feature class. And that's something that we're going to want to fix. So that's what we're working on now. So we'll go ahead and accept that, hit OK. Our feature class is added as a layer in the table of contents, and you can see all the subtypes that are associated with this come up as different symbology in here. And now nothing draws in our map because, again, the data model is empty and there's no data in here, so you don't see anything drawn on the screen. Now to assign our spatial reference, what we're going to do is go to the Customize menu here, go to Toolbars, and add the Distributed GeoDatabase toolbar. And you'll see that all of the buttons are grayed out on this except the very last one for Extract Data. So we're going to select that. And then it asks us, what do you want to extract? And we just, again, want the schema only because there's no data in the model yet. And which GeoDatabase do you want to extract to? We'll select the GeoDatabase option. And then in this box here, you see it defaults to our standard folder that we've been working with. And we're just going to select everything from extract output towards the end here. And we're going to name our new GeoDatabase something more permanent. I'm going to name it the name of my institution here. And I'm going to put a .gdb on the end of it to signify that we want a file geodatabase. And I'm going to select the Show Advanced Options checkbox here so that we have the chance to assign our spatial reference. We'll click Next. And again, it brings up a list of all the different objects in the data model. That's all great, so we'll hit Next. And then here on the Output Spatial Reference screen, we can select the option to specify a new spatial reference. And the data set of base map is what we're trying to assign it to. And then everything inside that base map feature data set will also get this coordinate system. We'll hit the Edit button so that we can select a coordinate system. And then it will bring up a number of folders here that contain different coordinate systems for different parts of the world and different types of projections. At this point, it's important to know which coordinate system to project. Now, the easiest way to figure this out is to contact your local government, whether that be a city or county, province, or even state, and ask their planning department what they use for their GIS system. For the United States, it's very common to use the state plane system, and so we'll go into projected coordinate systems, go to state plane, and select NAD 83 US feet, because that's what my local government uses, and that's what, if you're living in the United States, that's the most recommended option. And in here, you'll see that there are lots of different state plane coordinate systems depending on what part of your state you live in and what state you're in, of course. Now, another way that you can determine which one of these to use if you're living in the United States is to just search on the internet for state plane zones map, and that'll bring up a map that will show you how each state is broken up into different zones, and you can figure out based on where you're living which zone to use. In my case, I'm living in California. That's where the UC Davis Arboretum is. And I happen to know that we're in Zone 2, so I'll select that one and hit Add, and then hit OK. You'll see those details get added in here. We'll hit the Next button, and we have no further actions that we need to perform, so we'll hit Finish. And now we're going to see a similar process to what we saw when the XML document was being imported into our temp GeoDatabase. It goes through and it's basically extracting everything from our temp GeoDatabase into the new UC Davis Arboretum GeoDatabase that we defined. And this time it's assigning the coordinate system to all the different feature classes and data sets inside of the data model. Unfortunately, we're not able to do this during that first importation step. That's why it's such a complicated process. But I do want to reiterate that instructions for doing this are in the Getting Started document if you'd like to follow along with text-based instructions. So we're going to just sit back and let this thing finish, and we'll pick up when it's done. Okay, and once that process completes, again, the window just closes. And we're just about done. So what we can do now is close our distributed GeoDatabase toolbar and go ahead and close ArcMap. And no need to save changes. We'll come back to and start a new document in a little bit. Okay, now we're going to go back into ArcCatalog. So again, go to our Start menu, All Programs, ArcGIS, ArcCatalog 10. And once our catalog is all loaded up, we're going to go back to the same folder we've been working with and take a look at the results of our export process. Okay, once again, I'm going to maximize the ArcCatalog window. And I'm just going to select on my folder connection here to see what we've got inside. And one step that we didn't do during that export or extract process was to add the version number of the data model to our GeoDatabase, and this will help us to be able to support you guys if you guys need some help. It's important for us to know which version of the data model you're using. So by adding that to the name of the GeoDatabase, it'll be really easy for you to track. So I'm just going to rename it and add 1.0.2, which you can see in the XML file name here. I'm going to put .gdb at the end so that we know that, or so that our catalog knows that this is a file GeoDatabase still, and then hit enter. And then if you right click and hit refresh, that .gdb will go away. And we can go ahead and take a look inside of this GeoDatabase and see how everything went. So if we double click on that, we'll see that we've got most of the objects here. Oops, looks like I double clicked twice here, so I'll hit cancel. Most of the objects here that we have in our temp GeoDatabase, but if we click on the temp one on the left here, we'll see that there's a few things that didn't make it over there. And that's due to the way that this the spatial reference process works. So to get the missing objects, we're just going to go ahead and click on them. And I'm going to click on Aerial Photography Catalog. I'm going to hold the Control key and click on Journal, and hold the Control key and click on Public Garden Tools. Then right click and hit copy. Go back to my UC Davis Arboretum GeoDatabase, and in the white space right click and hit paste. And then hit OK, and those objects will be copied in. One last step that we need to perform is that the Aerial Photography Catalog, which is a container to hold all of our different aerial photography that we might have. We might get some from multiple years. They may be made up of multiple files. We can put all those in this container. But it didn't get a spatial reference assigned to it. So I'm going to right click on it and hit Properties. And then on the XY coordinate system tab, we'll see that it says Unknown. So what we can do now is just hit the Import button and import the coordinate system from our base map feature data set that we've already assigned it to. So from the drop down, select our folder connection to our folder we're working with, go into our new GeoDatabase, select base map and hit add, and you'll see all that information gets copied in. Go ahead and hit OK. And now we're all done getting the data model installed, and we're ready to take a little bit of a tour of it. Okay, so let's take a little bit of a look around and under the hood of the data model and revisit some of those GeoDatabase concepts we discussed towards the end of Lesson 1. So let's start with our air photography catalog and go ahead and click on that. And to find out more information about what this particular thing is, let's click on the description tab here. And what we've done is we've gone through and filled out a lot of descriptive information about each object in the data model. And here we'll see the name of the object at the top, and then what type of object it is, raster catalog, and then some tags that we filled in that will help you to search for things. So if you were looking for somewhere to store a particular thing like imagery or aerial photography, you could use the search feature in ArcGIS, which is available from Windows Search. And you could search for something like imagery or aerial photography, and the results would include this object as a placeholder or a place where you could put that imagery. So under summary, we'll see that this particular object is used for all aerial photography in its original unprocessed format from the data source. So if you received a CD or a DVD, or a flash drive full of imagery files, you could copy those all into or load those all into this catalog and keep them. And then if you received another disk or another flash drive full of photography a couple years down the road, you could load all those in there as well. So this serves as a one big container for all that photography. And let's go ahead and get out of this by clicking on the Contents tab and then the up one level button here. And that gets us back to the view we've been working with. And let's go ahead and take a look at some of the other objects that we have in here. So let's first look at the enclosure table here. So if we want to find out what that is, we can look at the description, and we'll see that its summary says that it's a table of animal enclosures. If you work at a zoo or another institution that has live animals, it's pretty common for you to have enclosures to keep those animals in, right? So because enclosures can be either inside of a building or part of an exhibit or contained by some kind of fence, we don't necessarily draw in the actual enclosures, especially when they're inside a building, because this data model is not really concerned with interior spaces so much as outside spaces. But what we do is we track them in a table, so that if you have, say, a structure or a building with 5 or 6 or more different animal enclosures in there, we set this up so that you can type in and track lots of different descriptive information about those animal enclosures, such as what type it is and what kind of animals are inside of it. But we are not actually drawing those in. So that's why we're storing this in a table, because a table does not have any spatial component or any geometry associated with it. So that means it doesn't draw any information on the map. It's simply attribute information. And what we've done is we've related that to other things that define that space. So if we click on Contents here and up one level again, we can see that right under Enclosure is what we call a relationship class. And we can expand that here so you can see relationship class. And this relationship class is that enclosure has barriers. And what that means is that a particular animal enclosure may be defined by barriers, which could be fences, walls, perhaps a moat, depending on how this animal enclosure is defined. And what this relationship class does is that all of the different barriers, which they could be a combination of fences and walls and moats, whatever is creating this space for the animals, when you click on any one of those features, that the barrier features that define this enclosure, you'll get a list of the animal enclosures that are inside of it. So we'll play with that a little bit more as we work with the data model, but it's important to know about these relationship classes and how they work. And you'll see here that there's a number of other tables, and we can click on the description for each one of these, and we can additionally look at some of the fields that it has. So for enclosure, we can right click on this guy and get properties, and it will open up to the properties here, And we can look at the different types of information that are associated with this. So if we look at fields, we can see that each one of these entries into our table has a unique ID called an object ID that's assigned automatically by ArcGIS. It has an enclosure code, which is also a unique ID that's used by the data model that you will fill in on your own, which most conveniently we can set that equal to the object ID, and we'll work with that later on. And then it's got an enclosure subcode, an enclosure type, a name, the date it was constructed, a link to a construction document. So if you have either on the web or on your computer a blueprint for this enclosure, you could link to it here. Whether or not the enclosure has a shade structure, plant protection, and then some additional ID fields which link the enclosure to other features, so such as an exhibit. So if you've drawn in our exhibit feature class, you've drawn in the boundaries of a particular exhibit at your institution, you would enter the exhibit ID of that exhibit in the exhibit ID field, and that then links those two things together. So when you click on the exhibit, you'll get a list of all the enclosures that are inside of it. And again, we'll work with that more later. If we look at the subtypes tab here, we can see that the subtype field is enclosure type, which we see right here, enclosure type, right? And the default subtype is plant, because this is usually for botanical gardens. Sometimes you may have a special type of enclosure, might be a plant enclosure if you've tried to protect sensitive plants with a fence, or they're inside of a building, etc. But then you'll see a list of all the different subtypes we have set up. So they're basically based on what type of enclosure this is. Is it an amphibian? Is it a bird? Enclosure, insect, fish, mammal, etc. So those are all listed here. And enclosures, subtypes, just further define the type of object that we're working with. And then we can click on the relationships tab here and see some of these different relationships that are set up for enclosures. So as we mentioned, a barrier could define an enclosure, so there's a relationship between enclosures and barriers. An exhibit may contain enclosures, so there's a relationship there. And a structure, like a building, may have enclosures. So those relationships are all set up so that when you click on those objects on the map, you will get the associated enclosures. So let's click on OK for now and get out of this. The next thing we want to look at is our base map feature data set. Now, a feature data set, if you recall our discussion from the previous lesson, is that a feature data set is sort of like a folder that contains different feature classes and objects that share some kind of geometric relationship. So in this case, we have something called a topology, which is a group of rules that govern the quality of your data and how different feature classes and features on your map relate to one another. So let's go inside our base map feature data set and take a little bit more of a closer look at the topology. So if we scroll down to base map topology, select it, right click on it, and get properties on it. And it takes a little bit to load everything up, but if we click on the feature classes tab, we'll see a list of all the feature classes that participate in this topology and their associated ranks. Now, pretty much everything inside the base map feature data set, every feature class participates in this topology, and they have certain ranks, and the higher the rank, the less likely objects are to move on your map when you're using some of the automatic correction tools, and we'll talk a little bit more about that as well. So if we go to the rules tab here, this is really where the meat of the topology is. We have a lot of different rules set up that govern the geometry and the quality of your data inside the data model. So for instance here, we have this particular topology rule that says structure must not overlap with planting area. And let's see what that means by clicking on the description tab here. It says an area from one layer must not overlap areas from another layer. Any area where features of the second layer overlap a feature of the first layer is an error. So in our case, we're talking about structure must not overlap with planting area. And if we look at this image here, the graphic, and we think of a structure like a building being in blue, and a planting area, or otherwise thought of as an area of your garden that you plant plants that you may have defined, may have named, and drawn in on your map, and is in yellow here, then this area in red is showing that there is an overlap between the blue and the yellow, or the structures in the planting areas. And that area red shows as an error. So if you've gone and you've drawn those objects in your map, and you did maybe a little bit of a sloppy job drawing those in, and there's a little overlap, the automatic topology rules inside of the data model will show that overlap area as an error and give you options to easily correct them, which makes maintaining your quality of data a lot easier and fixing errors a lot easier. So there can be a special case too where maybe you have a building that overlaps a planting area, and it's actually not an error. It's actually how it works. So maybe you have a building that has like a large awning that or overhang that has been that is included in your drawing of that object, and it actually does overlap the planting area. Well, when that error comes up, you can mark that as an exception anytime, and this is true of any of the other rules, so that if there are exceptions to these rules, you can deal with them without having to have those things show up as errors all the time. So let's click OK on this, and I encourage you to go through and look at the rest of these topology rules. You can see that there are quite a few of them because there's so many different things inside the data model. But the descriptions here are usually pretty good at explaining those rules and telling you what they're all about. And we'll work more with topology tools later on in the series. So go ahead and click OK, and let's look at some of the other objects that are inside the data model. So one of the main things we want to look at is these little icons on the left show us kind of what type of object we're dealing with. So in this case here, this one has little polygons with little dots inside of them. This is a polygon feature class. And areas of interest, we draw polygons to define areas that we're interested in, and that's why that's a polygon feature class. And for instance, barriers, which we already discussed, things like fences and walls, those are usually linear features, so we represent those with lines, thus the icon you see next to it. And then also things like benches. Benches are pretty small. We generally don't want to define the boundary of them. We use points to represent those, so they just show up as points on the map, thus the icon here. There's obviously an icon for our relationship class and for our topology, which we've already talked about. If we scroll down here, you can see how many feature classes are inside, or different objects are inside the data model. If we scroll down to Plant Center, this is one of the most important types of feature classes in the data model. We'll talk about that in just a second, but I wanted to point out the final type of feature class is called annotation, and that's a little A icon. And annotation is used to store labels that you want to print on your maps or have show on your maps. And now ArcGIS has the capability of producing labels on the fly for whatever you'd like. But for certain things that we want to stay in a fixed position on our map and always have them be in the same spot, we use annotation. And it's very common for people that when they're creating maps of their garden, they want to label the plants. They want to have their scientific name and their accession number visible on those maps, maybe a leader line between the point and the actual text. And we store those in this annotation feature class. And we'll work with that more in future lessons as well. So let's take one look at one of the feature classes here. Let's look at the Plant Center feature class, as it's one that generally everyone's interested in. Let's click on it and right-click and hit Properties. And let's just go through and look at some of these tabs that are in here to get a little bit a better feel of what some of our properties are. On the General tab, we'll see that the name of the feature class, and then something called an alias, which is a more common or friendly name. So Aliases can contain spaces, unlike the actual names of feature classes. And we've named all these things, but you're welcome to go in here and change this to whatever makes more sense for you. If it helps you to understand what this particular feature class is for, then feel free to do that. But keep in mind, when you change the alias, it doesn't change the name that you'll see when you're in our catalog. We see our XY coordinate system, which has been automatically assigned through our extract data process that we did a little while ago. We can look at the fields. Just like our table had a list of fields, our feature classes have fields in the same manner. The main difference here is that our feature classes all contain this shape field. So we saw our object ID field in our enclosure table, but it didn't have a shape field because it doesn't have any geometry. There's nothing, no points or lines or polygons that get drawn on the map. But in the case of a feature class, like this plant center one, it's a point feature class, and different points need to have their coordinates stored somewhere. So this shape field is where those get stored. And you won't actually directly interact with this field, but when you place points on the map, or maybe map them with a GPS, that data will be stored in this shape field, which is kind of out of sight and out of mind. There is an ID field, which is often for every object or feature class. It's always, the ID field is always named the same as the name of the feature class. So in this case, it's Plant Center. And this ID field is an ID number that you will populate and put in there and maintain yourself. And this ID number is used to link different feature classes together, such as in the enclosure has barriers relationship. And we'll work with those more later, so don't worry about those too much right now. But if we look at some of our other fields, there's a field to store an accession number for this plant. There is a plant center type field, and that indicates that we have subtypes. So if we take a quick look at the subtypes, we can see the subtypes tab. We can see that, yes, in fact, the subtype field is plant center type, and it defaults to plant center, and then we'll see a list of the different subtypes that we have here. So we almost always have an unknown subtype for, sometimes you just don't know what you're mapping or what it's supposed to be. Maybe someone else did it and it's unsure. You can always change things to unknown, so that's always present. But more importantly, you'll see that we have a plant center subtype and a mass planting subtype. Now, the plant center subtype we would assign to any plant that is an individual. So if it's a standalone, like a tree or a shrub that just gets a single point, we will assign it to the plant center subtype. Now, conversely, if we have a group of plants that are too complex, meaning that they are all grown together to map as individuals, or they are too dynamic, say they change a lot from season to season or year to year, sometimes we just want to draw a polygon around the outside of those, which we would store in our mass planting feature class. And we would like to be able to say that, oh, we know that there are 1, 2, 3, 4 or more species growing inside of that. So if that's the case, then we would put a single point from the plant center feature class inside of that mass planting polygon, arbitrarily placed, for each plant that is, each species that is inside of that mass planting. So if we have two plants that have grown together, we've drawn a polygon around the outside of those, we would place or two species, we would place a point that is in the mass planting subtype inside of that polygon for each species that we have. So there would be 2 points in that case. And don't worry if you don't understand that at this point. We're going to work extensively with that throughout these exercises. So let's go back to our fields, and we can just quickly look down at some of the other fields. There's a growth habit field. There is a family and lots of taxonomy fields like genus and species. There is a complete scientific name field, an abbreviated name field, a common name field, and a field for plant condition, size, etc. All kinds of information we can track about our plants. One thing of interest, though, is that under our plant condition field, when we click on it, it brings up more information down here. And we can see just like each feature class has an alias, each field has an alias, which you can feel free to go in and change to something that's more meaningful to you if you'd like. There is a default value, so every time we create a new point, this field will default to the value alive. Hopefully you're mapping plants that are alive, so we've set that as a default value. But then you'll see that there is a domain here, and that domain is assigned to plant condition. And what a domain is a list of valid values for this particular field, so that when you're entering information about this particular plant, you'll get a drop-down list of different values to pick from. And let's go ahead and take a look at a domain in more detail. So to do that, let's click on OK. And then on the left, where we see our UC Davis Arboretum, or whatever you've named it, GeoDatabase, we right-click on that and get Properties, and then click on the Domains tab if it's not clicked already. And then let's scroll down, and you'll see all the different domains that we have assigned in the data model. So there's quite a few of them, and these really help your data entry and data quality maintenance efforts. And let's look at the plant condition domain here. So if we click on it, we'll see that the description is it's a list of valid values for the plant center feature class and the plant condition field within it. And then down at the very bottom, we'll see a list of all the different values that are available for that field. So as we mentioned, we have our alive condition, which if a plant is alive, but we don't have any more information, like exact condition assessment on that plant, this is a generic condition that we can enter. But then we also have more detailed things like excellent, good, fair, poor. And then further down, we have removed and dead. So these are interesting ones. So if a plant is removed or a plant dies, we don't actually delete the point off of our map. What we do is we change the condition to removed or dead, and then we'll set up something in ArcMap, which we'll work with later, that makes it so that we don't see any plants that are listed with a condition as of removed or dead. And what that does is it allows us to keep that data. We won't see it anymore, but we'll keep that data so that if this plant comes back to life, say when we removed it, we didn't get all of it, and it starts growing back, or it dies back for a season and then comes back the next year, we can change the condition from dead or removed back to alive or one of the other more detailed conditions, and then that point is back. We don't have to go out and remap it again. We've already have the location of that plant. It just shows back up. So it's a great way to keep the history of what's going on in your collection. So yeah, that's why we have those.
All right, so that concludes Lesson 2. So today we learned how to download the data model from the Alliance for Public Gardens GIS website. We learned how to install the data model to a new GeoDatabase and change the spatial reference. Then we also took a brief tour of the features that the data model has to offer. If you need more help installing the data model or changing the spatial reference, I recommend downloading the Getting Started document from the Alliance for Public Gardens GIS website. In the next lesson, Lesson 3, we will learn how to digitize base map data in ArcMap. We'll also take a more detailed tour of some of the features that the data model has to offer.